Education is a journey of exploring and discovery. Best Buy Children's Foundation and Ball State University have teamed to make the journey inspirational. Through special interactive electronic field trips, millions of America's school children are able to travel the globe in search of adventure and new discoveries. Best Buy and Ball State University believe that when you educate a child, you build a future. When you inspire a child, the future is limitless.
When the Hall of Fame comes up, it's baseball elites. It means a lot to anyone who plays professional sports to have something of theirs in the Hall of Fame. We went a couple of years ago, and I got a chance to walk through it and look at some of the things that were on display. It was a lot of fun being there. Small town, and you know, you just don't expect something that small to have the impact that it does over the nation, and it does.
When I was making a decision about college, it all came down to one thing. My major, communications. I wanted to be at a place where I could get the very best education and have hands-on experience.
Ball State is definitely the place for that.
Academic excellence at Ball State University.
What a difference you made in my life.
Hi, I'm Matt Dinwiddie, freshman at Burris Laboratory School in Muncie, Indiana. Welcome to Fastballs, Flips, and Physics. We're here with a very special friend today, Jane Forbes Clark, chairman of the National Baseball Hall of Fame and Museum. We're going to have a lot of fun in the next 90 minutes, so let's get things started. Jane?
Thanks, Matt. It's great to be here in Jupiter, Florida at Roger Dean Stadium, which many of you know is the spring training home of the world champion Florida Marlins and the St. Louis Cardinals. And as Matt told you, we're here today to talk about science on the sandlot. And I'd like to introduce you now to one of our very special hosts, Ozzie Smith. He's a 13-time Gold Glove winner, set 6 fielding records as a shortstop, played in 15 All-Star games, and his incredible acrobatic fielding and talent made him a great player, and he was inducted into the Hall of Fame in 2002. And we're thrilled that he is our ambassador of education.
Thank you, Jane.
Ozzie, you were famous for your acrobatic plays on the field and for your flips, which is something we're not going to ask you to do today.
Thank you.
But they seem to defy physics. Yet I know you had a very scientific approach to the game. Tell us about that.
It's real simple, Jane. Physics was not one of my favorite subjects in school, but the only thing that I knew about physics was that the shortest distance between 2 points is a straight line. You know, so I tried to get to the ball as quickly as I could and tried to get rid of it as quickly as I could. Playing shortstop was my domain. It was a way for me to get away from the rest of the world. When I was out there, I was able to create as I felt, and I had a freedom like no other, you know. So out there, I was able to do the things that I felt that I was put on this earth to do. And it was just a great experience. And I think the kids that are out there today, the students, are going to have fun as we go through this whole process of trying to explain how the physics and baseball come together.
Ozzie has taken a love for the game, great natural ability, and combined it with an intuitive knowledge of physics and science to make him one of baseball's greatest players. And for more on how we're going to do that, learn more about it, we need to go back to Matt and get started on this afternoon's program. Matt?
I'm here with the Hammerheads mascot, and we're going to get this show started.
Smith corks one into right, down the line. It may go. Go crazy, folks. Go crazy. It's a home run, and the Cardinals have won the game on a home run by the
Hey, I don't know how you could not be excited about this program after an opening like that. Welcome everybody to Roger Dean Stadium. And not only are we joined by students from Independence Middle School here in Jupiter, Florida, the Weiss School in Palm Beach Gardens, Florida, but millions of students across North and Central America for our Fastball, Flips, and Physics program. You're going to meet a lot of kids during today's program. Students just like those of you who are watching back in your classrooms. You've already met Matt Dinwiddie, who helped open the program. We've got Matt Hayden, we've got Juan Gonzalez, we've got Bonnie Kaminsky, but we've got 3 other students who are right here with me, and they must feel like rock stars right now. You guys, this is going to be so much fun. Why don't you go ahead and introduce yourselves to us?
Hi, I'm Madison Carlin. I attend 8th grade at Independence Middle School here in Jupiter, Florida.
Okay.
I'm Taryn Smith, and I attend Parkway West Middle School. I'm in 8th grade also. I'm at St. Louis, Missouri.
Okay.
I'm Bryce Rector, and I go to Burris Laboratory School in Muncie, Indiana.
All right, so we have Madison, Taryn, and Bryce. Now, Taryn, is there any coincidence that you share the last name of one of our program co-hosts today?
Actually, he's honored enough to be my dad.
Oh, okay, so now we know the real story. Well, we're honored that you're on our program, but in addition to the students who are on today's program, we also have some teachers, because we know that there are teachers in the classroom as well who are going to be enjoying the show. Madison, why don't you tell us a little bit about the teachers who are on the program?
Well, we have 4 teachers joining us today who know a lot about physics, and they are Brian Carr, Nancy Watson, Mike Dodrell, and Dr. Jim Sherwood.
And I understand that Dr. Jim Sherwood is the director of the Baseball Research Center at the University of Massachusetts Lowell, which does all the testing for Major League Baseball. That's pretty exciting. All right, now, we also have some other people here, Taryn.
Yeah, we have some Baseball Hall of Fame staff members.
Really?
Yeah, one yourself.
I get to be on the show?
Yeah, something like that.
Oh, thank you so much. Maybe.
Yeah, Jim Gates, who's the librarian, and Dale Petrosky, who's the president of the Hall of Fame.
All right, Taryn, very good. Now, and then later in the program, we're going to be joined by another former major leaguer, a guy who had a very accomplished career himself. Bryce, tell us a little bit about him.
Yeah, we have Dennis Martinez, one of the greatest pitchers of the game. He finished his career with 245 wins, and in 1991 pitched a perfect game, which means out of 27 hitters, not one got on base.
That's amazing. Now, Bryce, if I remember correctly, his nickname was?
El Presidente.
El Presidente. Dennis Martinez is from Nicaragua, so not only do we have the president of the Hall of Fame on the program today, but we have El Presidente as well, so a pretty distinguished lineup. Now, students are watching the show all over the United States, throughout countries in Central America. Millions of kids, just like yourselves, are tuning in today, and we want you to participate in today's program. Madison, how can they do that?
Well, you can call in and ask us questions, and that number is 1-866-279-8716.
Okay, and if you don't have a telephone that you can get to, or if the line is busy, and a lot of you kids out there are very computer savvy, Taryn, how can they communicate with us that way?
You can email us some questions also at ali.apple//sandlot.
Okay, and I think they're seeing that on the screen right now. All right. And if they email their questions in, Bryce, who will be on the other end to answer them?
Well, there's a bank of experts. There are thousands of experts out there waiting at the computers to answer your questions.
So all over the country, we've got scientists, baseball historians. They're all right there at their computers to answer the questions that you might email in today. You know, we've already talked about the great hosts of today's program, the students, the teachers, Dennis Martinez, but there's one other guy. He's Taryn's father. You've already met him. He's the great shortstop, Ozzie Smith. Let's learn a little bit more about his Hall of Fame career.
I think Ozzie Smith probably the best shortstop I've ever seen on AstroTurf.
He was an amazing player to watch.
I constantly looked at Ozzie and said, how in the world does he do that?
Well, he's the best who's ever played that game.
He was a competitor, he was a hard-nosed competitor.
College educated, intelligent, could communicate, had goals, had vision, had desire, had the right work ethic.
He's the one that they all kind of want to take after. Everybody wants to be Ozzie Smith.
Well, Ozzie's human highlight. Ozzie's a good leader.
When you see Ozzie play, you know he's one of the best.
He's the greatest defensive shortstop I've ever seen.
When they talk about how good this shortstop is and how good that shortstop is, there's always a reference to Ozzie.
And I think he changed the way people look at defensive players in the game of baseball.
No better shortstop than the great Hall of Fame Ozzie Smith, and he's here with us today to host the program. We're going to go now out to the Fun Zone. I think, Taryn, you're headed out there shortly, aren't you?
Yeah.
A lot of great things happening at the Best Buy Fun Zone, so let's throw it out there to Neil McPhail and Brian Carr. Guys?
Thanks a lot, Jeff. We're out here at the Fun Zone with Best Buy's Fun Zone. We're going to be doing a lot of activities out here that will help you to understand a little bit about the physics that we've been talking about. We've got a group of students here from Independence Middle School. And they're going to be here to help us as well. We also have a couple of students that are here as well. One of them is Bonnie. And Bonnie, I've been watching you an awful lot, fielding ground balls, throwing baseballs this week, and it seemed like you did a lot of fun things. What's something that you liked?
I really enjoyed being able to just get out and play the last couple of days, and working with Ozzie was really wonderful.
Yeah, it was really neat. Like I said, I saw you softening the hands and turning two and having a lot of fun when you're on the diamond. And Juan, a great athlete, a lot of fun to watch you play. And what were some of the things that you liked?
Basically, just being out on the diamond with Ozzie Smith was an incredible experience. We had Jim Sherwood, the professor from the University of Massachusetts, taught us a lot of stuff while we were having fun, so it was great.
It was a great experience, I know, from a teacher standpoint, too. We had an awful lot of fun. With me right now is Neil. Neil's from the Best Buy stores, and he would like to say a few things.
Hi, I'm Neil McPhail, Vice President, Best Buy Retail. We're standing at the Best Buy Fun Zone. Best Buy's Fun Zone typically travels from town to town, showcasing mobile technology. But today, it's going to be showcasing experiments from all these middle schoolers. Best Buy and Best Buy's Children's Foundation believe learning should be fun and interactive. To that end, Best Buy's Children's Foundation sponsors the electronic field trip series produced by Ball State University. Now, Brian, let's turn on the fun.
Hey, man, let's get it going. All right, hey, I'll tell you what. There was a guy a long time ago. His name was Newton, and he came up with all these laws that really has helped us in baseball. I know there's no way he thought it was going to really affect the game of baseball, but it has. So let's take a look and see how it works. Here we go.
Baseball. What a wonderful way to teach Newton's laws of motion, like the law of inertia. A body in motion or at rest stays in motion or at rest until an outside force acts on it.
The way I understand this is that a bat and a ball are going to remain at rest until someone actually picks up the bat and hits a ball. But every time you hit the ball, it doesn't mean it's going to be a home run. You've got gravity, air resistance, or even a fielder catching it. Let's see how this is done on the field.
Hi, I'm Jim Sherwood, Director of the Baseball Research Center at the University of Massachusetts Lowell, where I'm a professor of mechanical engineering. And with me is Ozzie and Matt. And one question that I often get at the Baseball Research Center is, why isn't every hit in Major League Baseball a home run? Well, as we saw from Newton's laws, it's due to gravity. It's the force of gravity pulling the baseball back down to the earth. Now, with respect to that, some good examples in baseball of Newton's law. The first law is a body in motion stays in motion until acted on by an outside force. What's a good example of that, Matt?
The catcher stopping the pitch.
Okay. And the second law is that F equals ma, force equals mass times acceleration.
A pitcher throwing the ball.
Okay. And the last one, for every action, there's an equal and opposite reaction.
Hitting.
Okay. And hitting is a good example of that. Now, with respect to that, what we'd like to do as a scientist is we need a set of units that we're going to use to describe what's happening. We talk about distance and speed. So as a scientist, I like to use SI units. So I like to use kilograms, meters, seconds.
Come on, Jim. Gee, I'm just a simple baseball player. SI and meters and all that stuff. In baseball, we know 90 feet, 60 feet, 6 inches, or miles per hour. Can you keep it in those terms?
Okay. Today what we'll do is we will use ounces for the weight of the ball. We'll use ounces for the weight of the bat, feet for distance, and miles per hour for speed.
Thank you.
Okay. Now then, also, as a scientist, I like to use the scientific method. I like to observe something that's happening. Then what I'm going to do is I'm going to come up with a hypothesis as to why it's happening as it is. I'll do a set of controlled experiments so I can see, well, if I change this, change that, how does it affect the result? And in the end, those experiments are either going to support or contradict my hypothesis. Now as a baseball player.
Yeah, I got to ask you here. And it sounds like That's like a scouting report to me. You know, when I go out there, I have to have an idea of what the hitter's tendencies are. Is that pretty much the same thing?
Yeah, it's the same thing. It's like you want to know something about that hitter, and then you're able to make a prediction as to what he's going to do and how he's going to do it.
This physics stuff is fun.
It is fun. See, you should have enjoyed it in school.
Matt, did you enjoy this stuff?
I enjoyed it now.
Yes, that's cool. I'm starting to understand now.
Yes.
Go right ahead, Jeff.
Okay. Now then, with that, what we have to understand with respect to baseball is the pitcher is trying to use physics to his advantage. He wants to put the spin on the ball to get it to curve one way or another way, get speed on there. And as a batter, what he wants to do is he wants to be able to swing that bat around. He wants to have some timing to hit that. So with that, there's something to do with reaction time. The batter has to understand when he has to start his swing to the bat. So what we're going to do now is we have an activity associated with...
No, I think we have a call we're going to take right now. Rochelle from Indiana. Go ahead, Rochelle.
I have a question for Ozzie. I was just wondering, have you always played shortstop, and is it your favorite position?
Have I always played shortstop, and is it my favorite position? Of course it is. It's where all the action is. So I've always, shortstop has always been my position. I've had no desire to play any other. Kyle from Florida, go right ahead.
Who threw the fastest pitch and how fast was it?
Who threw the fastest pitch to me? Actually, when I started playing in 1978, Kyle, there were 3 or 4 guys that could throw the ball well over 100 miles an hour. 2 were on the Houston Astros staff. One was J.R. Richards, the other was Nolan Ryan. But the thing that really made their fastball effective was the fact that they could throw great breaking balls, and that's one of the things that we're going to talk to Jim about a little bit, that what makes that ball break so well.
Okay, we have a call from New Hampshire. Charlie, what's your question today? Charlie, are you there? It appears we've lost Charlie. Okay, so what we want to do now is we want to look at reaction time. So we have an activity for that going on in the fun zone.
How you doing? We got Matt Hayden here with us. We haven't introduced Matt yet, but he's going to be doing some of the activities with us as well. And we also have Taryn. At this time, if the classroom teachers would get out their rulers and the sheets of paper that go with this activity of reaction time, we'd like for you to do it at this time. Okay? It's really, really tough to hit a baseball. It's one of the hardest things to do in sports. And if a pitcher's throwing 90 miles an hour, that batter has maybe 0.4 seconds to get the bat in the right place, in the right part of the ball to make contact. We use reaction time and other things. And Matt, what are some things that you use reaction time with?
Like video games, you have to be able to see what you see on the screen and then be able to react to how fast you're going to push on the controller or what you want to do. So that's a lot of reaction time.
Yeah, okay. Taryn, we had talked a little bit about pitching and the importance of some things with that. What were you talking to me about?
Well, like, you know, when the batter comes to swing, it might come right back at the pitcher. So the pitcher always has to be prepared.
Yeah, okay. Well, what we're going to do, Neil is going to be, he's got his sheet ready to go. And I think you got a question for him, don't you?
Yeah, Taryn, how do you think you're going to do?
I have natural reflexes, so, you know.
Okay, so in this activity, what we're going to do, we'll start with Taryn doing the reaction time. And she's going to take this ruler, and she's going to use her hands, or fingers, and Matt's going to drop the stick. And as Matt drops the stick, Taryn is going to squeeze and see how far down the stick that she can get it, how quick she can make this happen. All right, now you need to be doing this in your classroom. Now,
that looked pretty fast. 0.19 seconds.
Okay, so Taryn had 0.19 seconds. Not too bad, not too bad. Okay. Okay. At this time, let's. I'll tell you what, Mike. You got something really quick? Let's go over to Mike.
I have Sheena and Bryson here, and Bryson said that the meter stick's falling due to the attraction of gravity of the Earth. So what they're doing is trying to grab it, and it's falling, so that it's falling in a certain amount of time. A variation you can do with this is if Bryson would say ball or strike, then Sheena would have to figure out whether or not to grab it or not. Go ahead.
Ball.
Swung on a ball. Okay. Jeff, we're going back to you out on the field.
Okay, thanks, Mike. We're going to do what Mike was suggesting, that is, do balls and strikes. And with me here is Chloe. She's a 6th grader at Independence Middle School. You can see her classmates and as well as the students from the Weiss School are doing this activity. So I'm going to hold the ruler for Chloe, and we're going to see if she can grip it if it's a strike, because that would be a good pitch, or if she can let it go if it's a ball, because that would be outside the strike zone, and 4 of those would give her a free pass to first base. Chloe, you ready? Okay, here we go. Ball. Oh, Chloe. All right, you got to let that one go. Here's another one. Let's go.
Strike. Very good. All right, Chloe, that's a 7, so you're doing better. Here we go. Strike. Oh, she let that one go. That would have been a good pitch. So you can see Chloe's getting the hang of it here. We're working on it, as well as all of her classmates. And Chloe, can I say something? You rule. This is very good. Nice work. All right, Bryce, tell us a little bit about what we just saw here.
Okay, what we're trying to show here is that in baseball, you do use reaction time. And this is showing, like, when there's a ball pitched, you want to not swing, and swinging is grabbing in this. And when there's a strike done, you want to grab it as fast as you can. That way you don't miss it. So, yeah.
So it's a good physics activity. We hope you're doing it in your classroom. So we've shown now that science on the sandlot and the history of the game are one and the same.
It's time now for a sandlot moment.
Thanks, Jeff. That looks like an interesting activity. I wonder how well I do at that. Now, most of you have heard of the Baseball Hall of Fame in Cooperstown, New York, and you're aware of the many great ball players who have been selected for induction. But did you know that we also have a wonderful museum where exhibits cover the complete history of the game and a library with more than 2.6 million items? This includes 12,000 hours of recorded media. Now, today we're going to select material from that collection to help illustrate the fundamentals of physics, which we're covering in today's program. The first thing we're going to talk about is reaction time. There was a great Hall of Fame pitcher by the name of Warren Spahn who once said, "Hitting is timing, pitching is upsetting timing." That's the very essence of baseball, but it's an important part of the physics of the game as well. Now, who better to illustrate this than the great pitcher Nolan Ryan, a man whose fastballs consistently approach 100 miles an hour. Now let's go to the video and see Nolan in action. That was Nolan Ryan, 324 victories, 7 no-hitters, and over 5,700 strikeouts during his major league career. Nolan Ryan was inducted into the Baseball Hall of Fame in 1999. Now let's move on to our next segment, linear and projectile motion.
Here we go!
A projectile, such as a fly ball in baseball, has two velocity components, the vertical and the horizontal. The horizontal distance it covers is also known as the range.
how I understand it is when you throw a ball, it goes up, out, and down. Let's see how this is done on the field.
Okay, Ozzie and I are out on the mound here with Dennis Martinez. And what we have now is a question from Kimmy in Florida. Go ahead, Kimmy. What's your question?
Yeah, this question is for Ozzie. Ozzie, I actually met you last summer. I'm a teacher at Independence Middle School, and I'm Gary Carter's daughter.
Oh,
and I met you this past summer, so I was like, this is kind of cool. But my class, I had a question for you.
Okay.
Wanted to ask you if you always played baseball in high school, and if you had a different sport that you enjoyed along with baseball.
Well, actually, I excelled at basketball in high school. That was really my sport. But when I decided to go to college, I had to do some soul searching, and I realized that baseball was really what I loved doing more than anything else in the world.
Okay, we now have a call from Erica in Indiana. Erica, go ahead. Are you there, Erica? Okay, so we have Dennis here, who's as you know, is a well-known pitcher. Threw that no-hitter back in '91, was it, Dennis?
Yes, 1991.
Okay. And what he's going to do for us now is he's going to give us a demonstration of speed. So we're going to be talking about speed and vectors in this segment. And he's going to throw some pitches, and Bonnie and Madison are going to be behind the home plate with the radar gun measuring those. And then he's going to pitch to Bryce.
All right, let's get it going. You got to use a 4 seams. That's the only way that you can throw the ball faster. So you're going to be fast and straight. So you got, let me work one out first. So I got to go the full motion now here to make it a little faster. Wow. I feel like I'm still playing in the big league already, man. Wow. So this is pretty good. I'm starting liking it now.
That last pitch was 75 miles an hour.
Oh, he's getting loose now. Yeah. Let it go, Dennis. Let it go.
Yeah, let it go.
What you can see, he's pretty much throwing a straight line pitch.
I need a spike,
Ozzie. This is projectile motion, but at the same time,
I want to sleep here, man.
It's so straight we could consider this to be linear motion. So that was 75 miles an hour there again.
It's going higher now.
Oh, yeah, right down the middle. Now, Dennis.
77 miles an hour.
Now my throat is sinking now.
Oh, good sinker. Whoa. That's that one you used to throw to me, Dennis.
Yeah, that's the heavy one.
The heavy sinker.
What we're seeing here is just speed. Okay, that was 76 miles per hour. So now Bryce is going to step in. Okay, Bryce, come on, why don't you come in? And with respect to what we just saw, we were measuring the speed. Now what Bryce is going to be doing while he's batting is he has to think about that speed. That's one thing, but he also has to think not only about that magnitude, but he has to think about the direction, where the ball is going. Is it going in? Is it going out, up, down? So we're going to use vectors for that. So Dennis, go ahead. You can keep pitching, and I'll talk about it. Now, at the same time, Bryce also has to be thinking about the effect of gravity on this, because gravity is pulling the ball down. He also has to think about the spin of the ball. What Dennis can do is he can put spin on the ball. He can make it dive quicker than gravity would alone. He can make it curve in, curve out. Whoa! So with this, Bryce, for a 90-mile-per-hour pitch, Bryce would typically have about 0.4 of a second from the time that the ball leaves the glove till he has to react and have the bat there ready to hit it. Now, what we want to see is Bryce is doing pretty good holding the bat down at the knob, but what we want him to do is choke up on it. Now, what he's effectively doing is he's changing the swing weight of the bat. He hasn't changed the mass of the bat at all. However, he's changed that his hands are closer to the center of gravity. He's going to be able to swing this bat a little bit faster than if he was holding it down at the knob and probably drive the ball a little harder. Now, he's not going to be losing any of the power of the bat by doing this because the baseball really only sees the barrel end of the bat.
I'm going in.
So by shortening the bat like this, same amount of mass of the bat is seen with the baseball.
Baby.
Don't hit it over there. Ozzie is over there, man. Okay. There we go. Yeah, that's better.
Okay, Dennis, that was great. Hey, Bryce, nice job in there. Was it easier once you choked up on that bat? Okay, so what he did was he effectively changed the moment of inertia of the bat. That's how we look at it as a physicist. As a baseball player, you probably looked at it as a swing weight. Well, I see that Ozzie's gone over there to first base, and what Ozzie's going to do is give us a demonstration of base running, and this is going to be an example of linear motion. Go ahead, Ozzie.
All right, as we talked about earlier, we're talking about linear motion, and linear motion is learning to go from one point to another in a straight line. And if I'm going to steal second base, one of the first things that I need to know, one of the things with scouting, is how fast a pitcher releases a ball and how quickly the catcher comes up out of his crotch to throw the ball to second base. And ideally what I'm looking for is a situation where if it's under 3 seconds, I know that if it's at 3 seconds, I know that if I can get to second base under 3 seconds, there's a good chance of my being successful. So we'll take Matt and Juan here, and we'll demonstrate this. What we want to do here is make sure that we're in a straight line to second base so that we're not coming from the outside in or from the inside out. So Matt, take your stance there and give me a straight line to second base. Boom. This is what we're talking about when we talk about linear motion. Go ahead there, Juan.
Now, Ozzie, I have a question.
Yeah, go right ahead.
Why must it be in a straight line? What is the point of running in a straight line?
Running in a straight line, we talked about the fact that the shortest distance between 2 points is a straight line. Okay. And so in this particular instance here, if you're going to be successful as a base stealer, you want to make sure that you run in a straight line to second base.
All right.
All right. There we go. Go. All right, great job there, Juan. Now, Mike from Florida, you have a question.
Hi, I was just wondering how many career home runs Ozzie has.
I had a total of 26. Janae from Florida, go right ahead. Janae, are you there?
How many years have you been playing baseball?
I played a total of 19 years in the big leagues. Robin from Florida, go right ahead.
Hi, Ozzie. Do you think about physics when you're playing baseball?
No, physics was the furthest thing from my mind when I played baseball. All right. We're going to go back to Jim Sherwood. Jim.
Go ahead. Okay. So Dennis, what did you think about that when Ozzie said he didn't think about physics when he was out on the field? What do you think?
Well, I never thought about it either because all I was concentrating just to try to get the guys out there. So I was trying to make my good pitches that I need to do. I tried to grip the ball the way that I'm supposed to make a break. So, but I know that has something to do with the physics, with the air going on.
Okay. I understand we have a question from Florida. I'm sorry I didn't hear the name.
It's Niletta.
Niletta?
My class wanted to know how far was the farthest home run hit, and did they use a wooden bat or a metal bat?
Okay, the question is how far was the longest home run hit? Well, I'm not an expert on the trivia. Actually, the guys at the Hall of Fame would be better to answer this one. But I am sure that in Major League Baseball, it was hit with a solid wood bat because that's the only kind of bat that they're allowed to use in Major League Baseball. So, but what we could do is we could actually go over to Jim Gates, and he might know how far the longest home ball was hit.
Jim, there are no official statistics kept on long home runs. They were hit with wooden bats, but it's reported that maybe Mickey Mantle or Willie Mays or Henry Aaron might have hit one 650 feet or so. No one really knows, but it's a good question. It's one we're always doing a lot of research on.
Okay, so now what we're going to do is we're going to go to Ozzie and Matt Didwitty at home plate.
All right, we're back here at home plate, and one of the things we want to talk about now is, I was a switch hitter, and when I came to the plate, one of the things that I had to think about first, I wasn't a home run hitter, so I had to think about using more of the field. As a left-handed hitter, when I step up to the plate, the one thing that the first thing that comes to mind is being able to hit the ball using the middle of the diamond all the way around to the left field line, and if I was hitting right-handed, I was thinking from the middle of the plate all the way around to the first base line, which gave me more area to work with. And the longer your shoulders in the strike zone, the more success you have. So I'm going to use Matt here to kind of demonstrate that. If in fact there's an inside pitch, which I'm probably not going to be able to hit the ball out of the ballpark. I wasn't a home run hitter, so I would try and take this inside pitch here and hit it back up the middle. If I wanted to hit the ball over the second baseman's head, I'd have to get the ball out over the plate a little bit more. And if I wanted to hit the ball to right field as a right field hitter, then this ball away from me, I'd look for the ball away. So if in fact you're a second place hitter, for instance, and you have to move the ball around a little bit, I'm going to ask you here, Matt, if I want to pull the ball down the third base line as a right-handed hitter, what do I have to do?
You get on the inside.
No, you have to get to the outside. You want to get to the outside. Yeah. And of course, if you want to hit the ball the other way,
you get the inside.
Inside of the ball. So we're going to let you demonstrate here for a second. We're going to let him take some swings. You ready to take some swings?
Yes.
All right. Hey, Charlie from New Hampshire, go right ahead. Charlie, are you there?
Baseball has ever reached, or the player has ever reached to catch a baseball.
Say it again, Charlie. I didn't get your question. Charlie, ask the question again.
What is the maximum height a baseball player has ever reached?
A maximum height? I don't know. That has to do a lot to do with your ability to jump. If you can jump, I was pretty good at jumping. So at 5'8", 5'9", I had a pretty good, I can leap pretty well, you know, so there were a lot of balls that were hit over my head that I was able to jump up, and my basketball skills that I used when I was in high school really came into play when I was playing baseball. Leah from Indiana, go right ahead.
I was wondering, do all aspects of baseball involve physics?
Yes, all aspects of baseball involve physics in some shape or form. Jesse from Indiana, go right ahead.
I have a question. How old was Ozzie when he first got interested in baseball?
I was 6 years old when I first started. I grew up, I was born in Mobile, Alabama, and my uncle started playing catch with me when I was 6 years old, and that was my indoctrination into baseball. All right, Matt, how's that feel? Now, we're going to see how your skills are here now. Hit the ball right back up the middle. Ah, come on, Dennis, let him hit the ball back up the middle. Get the ball out over the plate.
All right there.
All right. There we go. Hit a line drive now. Give me a good line drive to right field.
All right.
Which means now you've got to hit the inside of that ball. Oh, uh-oh. Gets a little tougher, doesn't it? Uh-oh. El Presidente, slow it down, El Presidente. All right, we're going to throw it back to Jim Sherwood. Jim.
Okay, I'm here with Bonnie and Madison, and we're going to do a little bit of discussion on vectors. Now, with respect to understanding where the baseball is going to go, we not only have to know how fast it is going, but we have to know the direction that it's going. And so to do that, we use vectors to describe direction. And what Bonnie and Madison did earlier is we laid out these bats. And what I want to do is, girls, let's crouch down around here. And we laid them out such that, imagine this as being the horizontal velocity of the component, and this is the vertical velocity of the component. So with this, what the girls did is the effective direction that the ball is going to be going is shown by these baseballs right here. Now, if we go over to this next setup that we have an equal magnitude of velocity in the vertical and the horizontal direction. This is at a 45-degree angle, and this is actually going to give you the maximum distance that the ball can travel. And then for the third one that we set up here, this is like a pop-up fly. We have a high velocity in the vertical, small component of velocity in the horizontal. This is going to be the direction that the ball is going to take as it leaves the bat. So what we want to do now is we want to do some examples with the Panzer Hummer. And we're going to start off with a shallow angle and increase the angle, see how the distance of the ball changes with respect to the angle on the Panzer Hummer. Now, there's a graphic that we have. Can you put that up on the screen now? Okay. So what we're doing is we have this graphic that shows the projectile motion. And what I've drawn right here, likewise, is a parabola that shows the projectile motion. So what we have here are the components of the baseball in the x direction and the component of the velocity in the y direction. Now, the velocity in the x direction doesn't change as the ball is moving. What does change is you have the force of gravity acting on the baseball, and these arrowheads right here are getting shorter and shorter until the baseball has a zero velocity in the y direction. Then it's accelerated back down to the ground, and it has an increasing velocity. So we'll see a demonstration of that with the Panzer Hummer. Go ahead. Okay, what we want to do is maybe set it up to a shallower angle than what we have right now. So can you make it a little, okay. Okay, that looks fairly shallow right there. What we want to do between dropping in each baseball is we want to keep the wheels moving fast. So what you can see is that the ball is following a parabolic kind of shape. And by changing the angle on it, Chris out there is having to move in or out to catch the ball. So you've got to make it shallower. Make it as shallow as you can there. Okay, try it again. Let's see how that does it. Okay, go ahead. Try one more. So with respect to this, gravity is really controlling how far that baseball is going. The Panzer Hummer is throwing it out at the same speed each time. So a pitcher can control the speed, but they can't control gravity. Gravity's always going to be pulling the ball down. So what we want to do now is we want to go over to Jeff for another example of projectile motion.
All right, Dr. Sherwood, thank you very much. And Ozzie, I have a question for you. You know Bryce, who was hitting in the cage earlier against...
Right.
He did a pretty good job, didn't he?
Yeah, he did. He has a good swing.
He's on my team. All
He's
right?
on your team?
Yeah, next Hall of Fame game, Bryce is on my team. He's a good guy.
All right, yeah, he did pretty good hitting against El Presidente.
Yeah, also on my team is Robbie the Redbird, who is the mascot for the Palm Beach Cardinals, and Hamilton R. Head, who is the mascot for the Jupiter Hammerheads, the minor league team for the Florida Marlins. And Taryn Smith is back with us again. We're going to do our own version of projectile motion now. This is something that you probably have all seen at baseball games, sporting events around the country. And Taryn is going to be the first one up. She's going to put an Ozzie Smith t-shirt, just like the ones that she and Bryce are wearing. And we're going to shoot those into the stands for the kids from Weiss School and Independence Middle School. Okay, Taryn, you're up. Step to the plate. Here we go. Let's see how she does here. This is projectile motion. Not like a Ponza Hummer, but a little bit different. There goes the first one, and it is... Oh, very good, Taryn. Nice job. Let's try another one, Bryce. Okay, drop one into the slingshot there. Let's see how... Oh, there, right over the heads. That's pretty good. So we're demonstrating projectile motion. You can see the arc of the T-shirts as they head up into the stands right now. All right, here we go again. These kids are they're anxious for these Ozzie Smith t-shirts. They want to wear them home, show them to their moms and dads that they were on the program today. Bryce is up now. Here we go. Oh, Bryce. Bryce.
They hit the Cardinals' arm.
Blame it on the Cardinals. Oh, come on. All right. We're going to go back now to Jim Gates in the dugout. And while Taryn continues to shoot some up and over the stands, they may even shoot one out to the Best Buy Fun Zone, although that one was a bit of a dud. We're going to go to Jim Gates in the dugout now for another look at how science and baseball history are one and the same.
It's time now for a Sandlot moment.
Thanks, Jeff. Looks like you guys are having a lot of fun over there. Just keep those away from the dugout. Now, we've been talking about linear and projectile motion and how that applies to hitting and pitching in baseball. Well, at this time, we're going to talk about a rule change that was implemented in 1969. It was meant to reduce an advantage of physics that pitchers held over hitters. Now, 1968 became known as the year of the pitcher, as earned run averages dropped to 2.98 in both the American and National Leagues. The great pitcher for the St. Louis Cardinals, Bob Gibson, had a wonderful season. He earned more than 20 victories and had an ERA of just 1.12, an incredible number. Let's go to the video and take a look at Bob in action.
And the Cardinals' Bob Gibson, after a shaky start, came on to win 23 games, losing only 7. For the second time, Bullet Bob was the Cy Young Award winner.
I'm going to use these dugout steps to illustrate this rule change. In 1968, the pitchers threw from a mound that was 15 inches off the surface of the playing field. In 1969, that was lowered to 10 inches, thereby reducing the angle of advantage that pitchers held when they were delivering the baseball. And you know it worked. Scoring increased immediately, and this became known as the Bob Gibson rule. But it didn't make any difference to Bob. For all the great players, they always find a way to succeed. In 1969, he won 20 games, and his ERA only went up to 2.18. Bob Gibson was inducted into the Baseball Hall of Fame in 1981. Now, let's move on to our next segment, momentum and energy.
Here we go.
Impulse is the average impact force times the contact time.
How I understand impulse is, if you don't want your hand to sting, you increase the contact time. Now let's see how this is done on the field.
Okay, we're here at the shortstop position, and I understand that we have some more phone calls, so let's go ahead and take those now.
Okay. Barrett from Maine, go right ahead. Barrett, are you there?
Yep.
What's your question?
Who did Ozzie Smith admire most when he was growing up?
Who did I admire the most when I was growing up? One of my favorite players was Roberto Clemente of the Pittsburgh Pirates. I lived in Los Angeles, and I used to go catch the bus out to Dodger Stadium when the Pirates came into town to watch Roberto Clemente do his thing. He had a very unique style, and not that I patted myself behind him, but he was a fun player to watch.
Okay. I understand we have another question. Peter in Florida, go ahead.
This question is for Ozzie. And have you ever hit a inside the park home run? And if you have, how many times?
No, I've never hit an inside the park home run. All 26 of my home runs went out of the ballpark. Saved myself some work. I didn't have to work as hard with my legs. So, no, I've never hit one inside the park.
Okay, we have a call from Brittany in Indiana.
Brittany, are you there?
Hi.
Hi, Brittany.
What is Ozzie's most memorable moment in baseball?
My most memorable moment in baseball. My most memorable moment would have to be the home run that I hit in the playoffs in 1985. That was, I think, the point in time in my career where people looked at me as much more than just a defensive player. So I would have to choose that as my greatest moment.
Okay, we have another call, Ozzie, from Missy in Missouri.
Hi, Missy. You there, Missy?
Yeah, hi.
Hi, how are you?
I'm great, thanks.
Good.
I'm from my physics class in St. Louis. Go Cardinals.
All right.
And we are wondering what your reaction time is.
You mean as far as hitting is concerned?
Yeah.
Well, it really depends on how fast the pitch is thrown, and Jim could probably address this a little better than I. But my reaction time really depended on how fast the pitcher was throwing. And of course, the faster he threw, the quicker I had to be.
Okay, let me just follow it up a little bit, Ozzie. There have been studies done on reaction time, and it varies anywhere from about 0.325 to 0.4 seconds for a player to react. Okay, we now have a call from Adrian in North Dakota. Would you go ahead, Adrian?
Hi.
Hi, Adrian.
Yeah. Hello?
Go right ahead.
Okay. We were wondering if Ozzie could do a backflip for us and tell us.
You mean intentionally,
and tell us
Adrian?
how his vertical and horizontal components compare?
Well, first of all, I'm not going to do a backflip intentionally. I gave that up in 1996. As far as vertical is concerned, I was a pretty good leaper. I had pretty strong legs, and as I mentioned at the early part of the show, I excelled at basketball in high school and had pretty good leaps. So my vertical was, I don't know exactly what it was, but it allowed me to jump a little bit higher than I am tall.
Okay. Well, I'd like to thank everybody for their calls at this time. We'd like to move on to our next activity. And the highlight film that you saw just before the camera came over to us, you saw some players making some great catches. And the one thing that you should have noticed when they were catching it, they didn't have a paper bag on their hand, but as they had their glove, they were moving it back. So what they were doing is they were increasing the contact time of the baseball with their glove, and thereby reducing the force of the ball on their glove. So Ozzie has a little demonstration here to do with a paper bag.
This is for all the kids out there. You probably have paper bags in your classroom. One of the things about being a kid was being able to use your creative skills, being creative with the way that you came up with games. And for me, I didn't have a glove when I first started playing, so I used a paper bag. I rolled a paper bag down on my wrist and played as much catch as I possibly could. Actually, I played by myself. I used a rubber ball to throw a ball against the wall and develop my hand and eye coordination, not knowing that it would help me ultimately become the baseball player that I became. And we're going to use Matt here for a second to kind of demonstrate that. But one of the things that using a paper bag will do is it will force you to consistently catch the ball in the same place. Ready, Matt? All right, you step over there. Boom. Now, I also want to say that you always want to try and use two hands as much as possible. But as you get better and better with learning to catch the ball and absorb it, as Dr. Sherwood talked about, you eventually want to be able to go to being able to catch the ball with one hand. And you'll see that it forces the bag or the glove becomes an extension of your hand. If I take my glove out of the bag, it's in this shape. So it actually becomes an extension of my hand. One of the other things we want to talk about here too, and we'll do this very quickly. He talked about changing the motion and direction. And as we can see here, if we can do it, throw it a little hard. You'll actually see me, you'll see the ball not actually go in the glove, but actually see it pop to my hand here. That's part of the magic of being able to change the direction of the ball. If we can see here, the ball is actually hitting the heel, and that all has to do with angles. I didn't know that when I started doing this here that this had a lot to do with physics, so it's part of my learning and making this being a fun exercise to do. Let's throw it again there, Matt. Get it down in my chest here, and hopefully you can see that at home, that I'm not closing the glove. It's just hitting the side of the glove here. We can get it down into my chest. Here we go, one more here. You actually see the ball bounce off the glove. It ricochets, and all I'm doing is changing the motion. So a lot of times at second base, especially turning a double play where you have to be very quick, sometimes this comes into handy. And now we're going to give you a slow-mo replay. You actually see the transference of the energy. Dr. Sherwood?
Okay, so that was a very good example of impulse. For impulse, what you're doing is you're changing the momentum of the ball. You have mass times velocity. You're not changing the mass of the ball, but velocity is both magnitude and direction. So Ozzie was redirecting that baseball. So we have another good example of impulse activity with Jeff.
Okay, Dr. Sherwood, we're over here in the stands right now, just behind first base, and we're all making our paper bag gloves. You can see the students, they've got them on their hands, they're holding them up for you. We've got some students who are actually playing catch, and they're showing the soft hand approach, so they're doing a great job with their gloves right now. Let's take it out to the fun zone, because I think they're making paper bag gloves out there as well.
One person here, one person over there. You're tossing back and forth here.
All these students from Independence Middle School and the Weiss School, they've made their paper bag gloves, so we're demonstrating the soft hand approach. And in just a moment, we're going to come back and we're going to do something with eggs. You can guess what that might be, but let's go to the fun zone right now.
Hey, Mike, you're up. Hey, we're out here at the fun zone, and we're going to have the egg toss started. What I need for you to do is stand right here. Come here, buddy. Stand right here. You're going to be partnered up with what's your name? John. John, all right, John. And what we're going to do is do an egg toss. Here comes Mike with the eggs. Don't throw it to me, Mike.
Let's go.
Come here, buddy. Come here. We're going to have you stand right here.
I got these two here, Brian.
All right. Oh, you got two right there?
There's your egg.
Perfect.
I can catch it in a minute.
Perfect. Okay, we're doing an egg toss, and you're going to use impulse to make the catch. Let's work really hard on this.
Go ahead.
Here we go. Toss to your partner. Nice.
And easy, nice
no,
and
hey,
easy.
out of your hand. Out of your hand. Out of your hand.
Oh.
Nice. Good. Soft hands. Let's scoot back a little bit. Come here.
Take a step back.
Take a step back. Take a step back. Go ahead.
Nice
and easy. Nice soft hands.
Catch it on your side. Toss it with your hand.
Whoa! You still in? Hey, we got a break right here.
Off to the side.
We got a break.
Nice. Step back. Step back. Let's take it. Go off to the side. Catch it to the side.
All right. Go ahead. Toss it one more time. Go ahead. Nice. What's your name?
One more. Take a step back.
John.
Let's get really far.
John, right here. How did it feel when you made the catch when it broke?
Same.
So it felt the same? You didn't feel it go? No. Well, it's a good thing it didn't break all over you.
Good
That's
hands.
for sure. Johnny did a really good job. Ladies, have you broken yours yet? No. Okay.
Go ahead. Take a big step. Big step. All right. Yep. There you go. Nice and easy. Go with the egg. With the egg. With the egg. Oh!
Hey, and there it goes. I think we've got some fried eggs down here. Mike, what do you think?
I think so. Scrambled.
Yeah. Okay. Like I said, we've been working with the soft hands, and the egg. You feel okay? Yeah. All right. You're not wearing the egg? No. All right. Hey, Jeff, let's send it back to you, buddy, with the little scrambled eggs, huh?
Hey, we're back over here behind first base, and we've got Chloe and Morgan and Taylor and Jack and Hamilton and Robbie the Redbird. They're all playing catch with their eggs. And so far, no broken eggs out here. We're using only the finest grade A fresh farm eggs today. And wait a second, guys. Hold on just a second. Let me see that. That is a hard-boiled egg. You two get out of here. All right, move it, move it. This is only for original fresh eggs. We're not going to have any of this hard-boiled stuff. Well, as you can see, we're demonstrating the soft hand approach here, and so far, no broken eggs. We haven't had any collisions at all. All right, you guys take a step back. We're doing the same thing that they are out in the fun zone, only we're doing better, all right? The team inside the stadium, we've not had a break just yet. Hey, while we're doing this, I understand Josh from Florida is on the line. Josh, what's your question today?
Hey, Ozzie.
Ozzie Smith. Go ahead, Josh, with your question for Ozzie.
What's the maximum number of home runs you've made in 1 year?
The maximum number of home runs I had in 1 year was 7, I believe.
Okay, keep going back. 7 home runs. Okay, Ozzie, what year was that?
Well, that's a good question. It was in the mid-'80s. I don't know exactly what year.
Okay, we'll have to look that up at the Hall of Fame library. Now we've got Danielle from Indiana on the line. Danielle, what's your question?
When you realized it was destiny for you to play baseball, what was going through your head?
Well, when I realized that it was destiny,
okay, keep going back,
and that
guys.
really came when I was a senior in high school, when I had to do some soul searching as to what I was that I really loved doing. And upon doing that soul searching, I realized that between basketball and baseball, with the hand and eye coordination that I had, that baseball was probably going to be my best way to play professionally.
Well, back over here behind first base, Ozzie, we've had 2 cracked eggs. Can you believe it? 2.
Is that your team members over there?
They are.
Uh-oh.
They dropped the egg. I'm sorry. All right, Chad from Florida, we've got a question. Chad, go right ahead.
Chad, are you there?
What's your question, Chad? Let's go to Alyssa from Florida now, who has a question. Alyssa?
Hi, Ozzie. When you were growing up, did you ever think you were going to play Major League Baseball?
Well, you know what? I didn't know, but I felt that I had the ability to play Major League Baseball. I never got drafted out of high school, which was a little discouraging. But I believed in myself and felt that if I continued to play and went to a school where I was going to have an opportunity to play every day and get the exposure that I needed, then I would have a chance to play professionally. And fortunate for me, that happened for me in I got drafted in 1976 by the Detroit Tigers. I decided to go back to school and got drafted again my senior year by the San Diego Padres.
Thank you.
All right, Amber from Indiana, go right ahead.
What's the difference in mass between a cork bat and a regular bat?
What's the difference between mass in a cork bat and
a
regular bat? And I'll let Dr. Sherwood answer that question.
Okay, with respect to that difference in the mass between a corked and an uncorked bat, what you're going to be doing is you're going to be drilling out some of the wood in the bat. So you're probably going to take out about an ounce or 2 of weight from the wood, and you're going to be replacing that with the cork. So what you're going to be doing in that case is you're going to be not only reducing the weight of the bat, but also the swing weight of the bat, or the moment of inertia. So it's going to be easier to swing the corked bat versus the uncorked bat. Okay, now what we want to do is we want to talk a little bit about collisions. With respect to a ball coming into a wall, let's say at 100 miles per hour, if it was a perfectly elastic collision, what it would do is it would bounce back at 100 miles per hour. Well, if you're going to bunt the ball, you don't want to bunt the ball back to the pitcher at 100 miles per hour. What you want to do is you want to take some of the momentum out of the ball. So Ozzie's going to give a demonstration of how you do that. And also from the physics principle, what we have to think about is the angle that it's going to come into the bat, as well as how it's going to be reflected off of the bat. So there are 2 important physics concepts that we have to consider with respect to bunting. And I'll let Ozzie and Bonnie demonstrate that.
Okay, Bonnie, if you'll go out there. One of the most important things, as Jim just mentioned, was that the angle becomes very, very important. That's why I'm going to talk about making sure that when we do bunt, we want to make sure that the knob of the bat is above the barrel. You want it at a 45-degree angle so that you can go down up and down in the strike zone. If I want the ball to go to first base, I've got to get to the outside part of the ball, and it's easier to get to the outside part of the ball by holding it at this 45-degree angle. Go ahead there, Bonnie. If I want to go to first base, if I want to go back to the middle, it's all about catching the ball or trying to catch the ball. It's as if I had a glove on the tip of my bat here and just allowing that ball to go into the glove, deadening it at the same time. And it allows you to go in any direction. But remember, the most important thing here is making sure that you keep the knob of the bat below the barrel of the bat. This angle here increases the chances of you popping the ball up. So you want to make sure you keep the barrel above the knob of the bat. Here we go, one more, and then I'll let you try. Bonnie, why don't you come in and demonstrate for us? Tyrone, we have a question.
How does your batting stance help you hit?
How did my batting stance help me hit? Well, you know, it really changed because when you talk about pitchers, sometimes they come from different directions. They come out of, they may be three-quarter, they may be over the top. So you want to make sure that you get in a position with your feet and your stance so that you have a very good look at how a total look at how he's releasing the ball. And the quicker you can pick it up, the more successful you'll be. Here we go, Bonnie. Catch the ball. Just catch it right off of the front of the bat. There you go. Don't drop the, remember, don't allow the head of the bat to get below the barrel, okay? There you go. There you go. Catch it. There you go. Catch it. Deaden it. Good job. Just deaden it. There you go. Gotta keep your eye on it. Good job. We're going to see the replay from Bonnie here. Good job, Bonnie. Good job. Good form, too. One more time here. Good job. We have any more questions? Here you go, Bonnie. One more. Hey, okay, we're going over to Jeff.
Ozzie, thank you very much. We're over here now. We've got Chloe and Morgan and Taylor and Jack back with us, along with Taryn and Bryce. Even though these four guys, they dropped the eggs, it smells a little funny over here because the eggs are right behind us. But we're demonstrating what Ozzie was just showing in the batting cage. And what they're doing is, some of the players you'll see are deadening the ball when it comes to the bat. They're pulling the bat back, they're conserving the contact, or they're actually increasing the amount of time that the ball and the bat have contact with each other. But then they're also demonstrating, just like Morgan is doing here, where they're hitting the ball forcefully and the ball jumps off the bat. It's not on the bat for very long, and certainly it's rolling back out onto the infield a little more quickly, giving the pitcher, the third baseman, the first baseman more of an opportunity. Oh, she just hit my foot there. That hurt. We're okay. No injuries yet out here on the field, but we're having a good time demonstrating this concept. And we're going to go out to the fun zone because they're also doing this activity out at the Best Buy truck. Let's go out to Brian and Mike.
Hey, thanks a lot, buddy. We're out here working the bunting right now, and Nancy's got them working on the stage. They're doing an awful lot of work. Out here on the cement, we've got our mascots out here. Mike's out here with the mascots. But like I said, up on stage, Nancy's doing a great job with them. We're still working on the impulse as well, trying to find some angles as well to try to get the ball to go in the direction that we want it to. Doing a good job with it. Okay, all right. I'll tell you what, Jeff, why don't you take it back from us here? We're having too much fun.
Okay. Brian, welcome back. Thank you very much. Hey, I have a question, Ozzie. Are you there? Hey, Ozzie.
Yes, go right ahead.
I want to know, when you were in a major league clubhouse, did you or your teammates ever use the phrase coefficient of restitution?
No, it sounds like a crime. No, in baseball, we never did use a coefficient restitution. And I guess Jim's going to talk to us about the coefficient restitution, whatever that is.
Okay. Do we have a question coming in, though? Okay, we have a question from Matt in Missouri.
Go ahead, Matt.
Hello?
Matt, are you there?
Go ahead, Matt.
Yeah.
Go ahead. What's your question, Matt?
What's your question, Matt?
Hello?
Yes, Matt. What's your question?
The baseball is pitched at 105 miles per hour. How hard would you have to swing a bat to hit the ball 450?
Wow, there's a lot of calculating going into that one. So you got 105 miles per hour, and you want to hit the ball 450 feet. I would say that you probably want to be getting a speed on the bat of 85 miles per hour for the tip speed at least, if not 90. But that's really just a guess. I actually have a nice long equation that if you send me an email, I can send you that formula, and you'll be able to calculate it. But we also would want to know something about the coefficient of restitution in order to do that.
Yeah,
but that's an excellent question.
You got to know the coefficient restitution before you can hit a ball 450 feet.
Okay, so do we have any more questions right now? Okay, so what we'd like to do now is I would like to introduce the idea of the coefficient of restitution. And with that, I have a baseball right here. And if you hold my clipboard for me a second, well, you want to do is you want to think about the baseball coming into a wall. If I throw it in at 100 miles per hour and it rebounded at 100 miles per hour, that would be a coefficient of restitution of 1. That'd be a perfectly elastic condition. Well, a baseball actually dissipates a lot of energy when it hits the wall. So a baseball has a coefficient of restitution for Major League between 0.514 and 0.578. So if it had a coefficient of restitution of 0.578, throwing it at 100 miles per hour, it would bounce back at 57.8 miles per hour. Now, do you know what that means, Ozzie?
No, please explain that to me, because you really have me confused here, Doctor.
Okay, so what we have here is we're looking at the liveliness of the baseball. And we have a video clip that we'd like to show right now that shows how we test for the coefficient of restitution. So this is in our research lab at the University of Massachusetts, and what we're doing is we throw the baseball at this solid piece of ash, and you can see the ball hitting the wall, bouncing back, and what we do is we measure the speed of the ball in and back. Okay, so what we're going to do with this is we need to know something about the liveliness of the baseball. And
let me stop you right there, Doc. So you're saying that if I knew what the COR, what do you call it?
Coefficient of restitution.
Coefficient of restitution, then I can choose the ball that I know is going to go further.
I'm sorry, Ozzie. They don't come from the factory with the coefficient of restitution marked right on there. But fortunately for you as a player, Rawlings is very good at making this baseball very consistent. Between the deadest to the liveliest ball, it's going to be about 4 feet. In reality, what could happen because of the wide range that they have for the COR, it could be 40 feet, but that doesn't happen. So you don't have to worry about that.
Okay, thanks, Doc. I feel much better now.
Okay, now what we want to do is we want to go over to Jim Gates, and he has some information for us.
It's time now for a Sandlot moment.
We've been talking about the change in momentum and how to catch a baseball, or in some cases an egg. There have been a lot of great catches in the past 50 years in baseball. Let's go to the video and see some of them.
With the count 1 ball and 2 strikes, Wirtz pounds the next pitch over Willie Mays' head, but there goes Willie. And he makes a miraculous catch as he stops a step short of the wall.
Count is 0-2. And it is a fly ball. It'll be tough to get to. Agee is going, and Agee makes a diving catch. He's up. Straight away for him in the outfield. And there's a drive to right center. Swoboda comes up with it. The target third. Here comes Frank Robinson. The game is tied. Ron Swoboda making another sensational catch for the Mets.
The throw misses a cutoff man. Shot on the plate. Out of the plate. Derek Jeter with one of the most unbelievable plays you will ever see by a shortstop.
Pitching for Brooklyn in the Yankees' 6th, with runners on first and second and 2 men away. DiMaggio smashes a long drive into deep left field. John Frito, after a desperate twisting run to the 415-foot marker, makes a sensational gloved hand catch of DiMaggio's terrific wallop.
There goes the drive down the left field line, and Sandy Amorous races for the ball, sticks out his glove just in time, and makes the catch. Let's have another look at that spectacular play. That double play is Brooklyn's 12th, the 19th of the World Series, both World Series records.
Now, if you've enjoyed these moments and are wondering how the resources of the Baseball Hall of Fame might be accessible for your school projects, we invite you to visit our website at baseballhalloffame.org. Here you can learn a lot more about baseball history, our educational programs, and our library collection. We hope you enjoy it. Now, let's move on to our next segment.
Here we go.
The Magnus effect is the force perpendicular to the forward motion on a spinning object through a fluid or gas. This is why a curveball curves.
How I understand this is when I put a topspin on the ball, it's going to drop quicker. Let's see how this is going to the field.
back on the mound now, and as you can see, Ozzie is holding two different bats. He's got an aluminum bat and a wood bat. And I often get the question at the Baseball Research Center as to which is it easier to use to hit a ball, the aluminum or the wood bat. And it's important to understand something about the center of mass with these. What I'd like to do is have Matt demonstrate how we can find the center of mass. So what he's going to do is he can take the baseball bat, and you guys out there can do the same thing. Take your baseball bats, hold it like Matt is right here, and he's going to move his fingers and he's going to slide them into the center. And where his fingers meet is where the center of gravity is on this bat. And we want to notice where it is on the wood bat relative to where it is on the aluminum bat. So it looks like it's about out here. So I'll hold this bat like this. And both of these bats are the same length. He's going to do the same activity with the aluminum bat, moving his fingers in to find out where the center of gravity is. So this is if you took all of the mass of the bat and located it at one point, you could consider it to be right here. So with that, keep your fingers right there. What you can see here is both of these bats are the same length. And they're probably about the same weight. But the center of gravity for the wood bat is out here, for the aluminum bat here. What that means is that for the moment of inertia, this wood bat is going to take more torque to swing it around to get the same speed as it does with that aluminum bat. Okay, let's take some questions. Okay, Ashley from Indiana, go ahead. Are you there, Ashley?
Hi. I wanted to, yeah, I'm here.
Okay, go ahead, ask your question.
In pro baseball, do they teach y'all science to make y'all become a better player?
No, in pro baseball, no, they don't teach us science to make us a better player. You know, it's actually just a part of what we do. And we just so happen today that this experience here gives it the opportunity to see how the physics of what we do actually, how those things are applied to the game of baseball.
Okay, let's check in with Jeff. I think we have some center of mass activity going on over there.
All right, thanks, Dr. Sherwood. We're back over here now next to the stands. This is Dr. Paula Neesmith. She's the principal of Independence Middle School. She and I got the broom out because we've got to go clean up those eggs, but we thought while we're on our way over there, we would try to find the center of mass on this broom. And what are you finding, Dr. Neesmith?
I'm finding that the closer I get to the heavy part of the broom, the easier it is to hold, and that I don't have to move the finger closest to the broom head at all.
Okay, so there's more weight on that end, therefore the center of mass is closer to the heavier end of the object. Okay, let's go out to the fun zone now and check in with Brian and Mike.
Hey, thanks a lot, Jeff. Hey, we're here with Nancy Watson, and she's working with Bryson right now on the center of mass with something that's just a little bit different than what you've seen so far.
In your classrooms, you're working on center of mass with a meter stick or a bat. Here we have Bryson finding the center of mass of a shovel. And oddly enough, it's not in the center of the shovel, but Bryson, where is that center of mass?
It's about right here.
And where is that?
More near the end of the shovel.
Okay, do you know why it's more near the end of the shovel?
Because the shovel part has more mass than the end of the stick.
Okay,
very good. Very good, very good. Okay, let's go back to the field and on the mound. Let's go for another pitch.
Okay, what we're going to do now is I want to talk a little bit about a cork bat. Now imagine that we have this wood bat right here, and I think we have a graphic that we can bring up that shows a cork bat and shows how to make a cork bat. And what we could do is, if I wanted to be sneaky, I could...
Now, you know that's illegal in baseball, Jim, so be careful.
Yeah, it's illegal, but I think I've heard some stories about people trying to do this.
Okay, all right, all right.
So the question is, it's like, is there really an advantage to using a cork bat? Well, it's kind of like using that aluminum bat right there, and it kind of continues with the question we were asked earlier about corking a bat. What you're going to do is you're going to reduce the weight of the bat. You're also going to move that center of gravity of this wood bat back here a little bit. A player is going to be able to swing the bat a little bit faster. But at the same time, you've taken some mass out of here, and really when the baseball hits this bat, a sound wave travels down the bat. And the distance that sound wave travels is how much mass that the baseball sees to get energy to leave the bat. Well, what you've done by corking the bat is you've taken away some of that mass, and so with that, even though you're able to swing the bat faster, you have less mass there, and it's really a trade-off that you're not going to hit the ball any faster. The cork isn't going to make the bat any livelier. What it is going to do, if it gives the player any advantage at all, is that the player is going to be able to move it up and down like this a little bit faster, and they're going to be able to hit the ball more often with the corked bat than with the solid wood
So Jim,
bat.
if we understand this correctly, using a cork bat doesn't give you any more of an advantage?
No, it doesn't give you any advantage at all. Just like when Dumbo jumped off the tower there holding that feather.
Oh.
He thought he could fly. Okay, we have a question from Lauren in Indiana.
Hi. We were going to ask, what does it mean to juice a baseball?
Oh, what does it mean to juice a baseball? Well, what it means to juice a baseball is that we're going to make it a little bit lively. And I know in 2000 there were a record number of home runs hit in April. And so with that, Major League Baseball was concerned whether the baseball was juiced or not. Well, they have a specification, as I talked about with the COR.
That's right. That's a coefficient restitution.
That's right.
All right. Good question.
So that value is supposed to be between 514 and 578. And we checked the baseballs, made sure that they weren't juiced. So what happens is if juicing the baseball actually makes the COR higher than what it legally should be. Okay, now what we want to do is we want to think about another part of circular motion. And we've got Dennis out here to help us with that, and that's the curveball. Now, with respect to a curveball, what's going to happen when you throw that, what's it going to do to the batter?
Well, first of all, it's going to do that they're not going to see the ball the same way with the same speed like a fastball. They're going to see something that comes right up to them, but then the ball will break away from them. So what we do is try to put pressure on the fingers, and we let the ball rotate with the force seam to go like this around them, and the ball will leave our hands going like to the hitter, but then as the force seam rotation going, they move away from them.
Gravity pulling it down.
That's what it is, gravity.
Okay.
I'm getting this physics thing now.
But it's not only gravity. What we have to think about here is you were taking advantage of the physics of the aerodynamics of this baseball. By the way that you held it, by the orientation that you put the spin on here, what you were doing is you were taking advantage of the drag force. As a ball moves through the air, there's going to be drag on it. Well, by having the spin on here, you've changed the relative velocity of the air moving on one side to the other side. And so what it's like is you're changing the amount of side force that's on the baseball, and it's analogous to like rowing a boat. If you have one strong person on one side and a weaker one on the other, and you're going to veer to the left or to the right.
You know what I think would be great? Why don't you show us, Dennis? Show us how you throw a breaking ball.
Yeah, I would be happy to.
All right.
Oh, yeah.
You still got a good breaking ball?
Oh, man. Watch out. Well, if you see, watch the curveball, what it does. It's going to be a good one for the big goal.
Oh,
see,
all right.
There's a little faster that doesn't break that much. So now I'm going to take off a little bit of speed so it can break more. That's what the breaking ball is supposed to be. You take it off a little bit of speed to break more.
Okay, Dennis, tell us is there something that you do to set that breaking ball up?
Yes, what I do is my wrist. That's the most important thing for that. Not only the rotation of the ball, but also the way you break your wrist. But the time you go there, you pull it with these two fingers. This one, that's the most important, the one you pull it to let the ball go up.
Okay, so you're putting more pressure on your center finger.
Right.
To let it spin
out of the thing and make it go down with it, with the force in. This, I'm going to try it again, so you can see the rotation of the ball. You're not... See?
And it gives it a downward motion.
But the main thing is the risk that you put in action to it. To make it ball rotate. Because it doesn't matter what the ball does with the physics thing, but if you don't make it work, it's not going to break.
Okay, and that all has to do with the wrist.
It has to be with the wrist. I'm going to do it again, a little faster now so you can see it. So that's, that's the one that I used to when I face Ozzie.
Yes, that's the one I got all the time.
Because I knew that it's one of the guys that always give me trouble because he tried to put the ball in play.
Do we have any more questions?
Okay, we're going to go now to Jim Gates.
It's time now for a sandlot moment.
Thanks, guys. That's a lot of fun there. You know, the Magnus effect in action. You see it all the time in Major League games, but you really know what's happening out there. Curveballs are wonderful things if you can learn how to throw them, and hopefully all you young men and women out there today have learned a lot about the game of baseball. Now for our final sandlot moment. Let's go out to the field where we have Baseball Hall of Fame President Dale Petrosky with Ozzie and Dennis to talk a little bit more about circular motion.
Dennis, you were one of the great curveball pitchers of your time, and why don't you show us the different grip between a fastball and a curveball and how it comes off your fingers?
Okay, we call it this four-seamer fastball. This is the one that it goes fast and it doesn't move that much. There's a straight fastball that the ball rotates with the 4-seamers like that.
Okay.
And then we throw 2-seamer, which is the one that is sink a little bit with less speed, but that's the one that it really jam the right-handed hitter and it's run away from left-handed hitter. That's the 2-seamer pitch that it go like that. But according to the physics person that we have here, with the gravity that the ball get this way, the ball tail down away.
Right.
So now with the curveball, it's a different grip. I grip my normal grip was here. A lot of people, have a different grip. So, but my grip is here mainly because when I let the ball go, the 4 seams, they try to help they rotate the ball. They make a better rotation.
Yes.
Okay, I think we're looking at some pictures of Jim Palmer. Now, Jim Palmer, for instance, had he had 2 or 3 different breaking balls that he could throw. You played with him. Talk about Jim Palmer a little bit.
Well, James was my idol. I mean, he was the man that I always admire him because the way he take care of himself, the way he was the idol for us, and the way and the pitching staff. So to me, I learned from him a lot, and the way that he pitched and the way he get people out, he was really impressive to me.
And now talk about Kerry Wood.
Well, Kerry Wood, I see him. He's a powerful hitter, but now he had a good breaking ball going for him after he got hurt. So basically, a lot of pitchers, they become a better pitcher after they get hurt. Why? Because now they emphasize more location-wise than throwing hard.
Now, we go from Kerry Wood then, or now, to Burt Blyleven when he faced you. And
Captain Hook, they called him.
He was the best curveball pitcher ever, maybe. Talk about his curveball.
And like he was talking about, he had a curveball that went what we call from 12 to 6. His breaking ball was thrown over the top, keeping that wrist straight, but it came more over the top than 3/4 or a drop down. So 19 years I played in the big leagues. I struck out 3 times in the game once, and it was against Captain Hook. Wow. That night he had the breaking ball working, and it gives you so little area to be able to hit the ball square when a guy has his breaking ball on. And anytime that a good pitcher that has great control has his breaking ball on, it's going to be a tough evening.
So you're saying the ball's not coming in this way, it's coming in this way, and you got to get a round bat on that ball.
In a very short area, So it's probably on that night more luck than anything if you're able to hit him.
Okay. Plus, if he changes speed with it, it's even tougher.
That's right.
Okay, great.
Got a phone call from Missouri? Blake, go right ahead.
Hi, I was calling to find out what was the hardest type of pitch for you to hit?
What was the hardest type of pitch for me to hit? Some nights it was a fastball, some nights it was a breaking ball, and some nights it was a changeup. So all of those things depending on how effective the pitcher was that evening, because when a good pitcher has his fastball working, his changeup, and his curveball working, you're in for a long evening. Okay, we're going to send it over to Jeff.
Okay, Ozzie, thanks. We're back here in the dugout now with Rob Rabenacker, the general manager here at Roger Dean Stadium. Rob, thank you so much. Your hospitality today has been tremendous. This has been a perfect classroom for millions of students all across the world.
Jeff, thanks for choosing Roger Dean Stadium, and on behalf of the Cardinals and the Florida Marlins, we're glad you guys were able to come down, and we hope you come back again.
We'll come anytime, and maybe it's a spring training game, maybe it's another electronic field trip, you never know.
We'll try to work on the weather for you as well.
I've got something for you, Rob. Ozzie's been wearing this special Hall of Fame logo cap. I've got one just for you. So we want to say thanks again for all of your hospitality here at Roger Dean.
Thank you, Jeff.
All right, it's been a pleasure. One of the other upcoming field trips that we'd like to tell you a little bit about is going to be in April. And that's a very, very special program that Best Buy and Ball State will be bringing to you from the Stephen Udvar Hazy Center, which is the newest wing of the Smithsonian Institute, housed at Dulles Airport. And it's all about the history of flight. Now, in 2003, we celebrated 100 years of flight with the anniversary of the Wright brothers' first flight. But the Udvar Hazy Center looks at a lot more than that, encompasses some pretty exciting things relative to the history of flight in America. And there is one aspect of flight that actually relates to the history of baseball. We're joined now by Doug Baldwin and Bob Vanderlinden, who are with the Udvar Hazy Center in Washington, D.C. Guys, welcome to today's program.
Thank you very much.
Tell us a little bit about the story of the 707 and how that relates to the history of baseball.
Well, the 707 in a way helped change the face of baseball. In the 1950s, baseball teams traveled around the country in trains, which meant they couldn't go too far because the average train distance, reasonably speaking, 5-6 hours, couldn't get you too far. So the team that was furthest west for many, many years was the St. Louis Cardinals. Starting in the 1950s, you get air travel. Now they can fly transcontinentally non-stop in 8 hours or less. But what really made the difference and what really helped move teams from the East Coast to the West Coast, particularly the Dodgers and the Giants, was the advent of jet travel in commercial aviation. In the United States, the first jet airliner is the aircraft you see over my shoulder right here. It's the Boeing 367-80, which is the prototype for the Boeing 707. And when the 707 entered service in 1958, it completely revolutionized air travel. Now you can get across the country in 5 hours or less. And that allowed teams to move, and they did so quite regularly for quite a while there.
That's right. Doug, tell us a little bit about the field trip that's coming up in April from the Ozzie Center.
Absolutely. We're here at the Ozzie Center, and it's holding the other 80% of the National Air and Space Collection that's not currently on display. So we have the really big stuff, the stuff that just won't fit downtown at the flagship museum. We have the SR-71 Blackbird, still the fastest plane ever to fly, jet-breathing aircraft ever to fly, the 707, which Bob just mentioned, as well as the Stratoliner, the Concorde, and, well, just some other really neat big aircraft that we're going to be able to share with you the history, the technology, and the science of flight. And we'll be picking up from where we left off from our Wright Brothers electronic field trip earlier this October. We're coming to you live from the Ozzie Center here in April, and we're just happy to do that, and we can't wait.
Doug and Bob, thank you so much. We're glad that you took the time to join our program today. We can't wait for your program in April. We're anxious to get back with you. And that's all for our show today. So as we leave the Ozzie Center in Washington, D.C., we're going to also depart sunny southern Florida here on the east coast of the Florida shoreline, Jupiter, Florida. It's been a beautiful day here at Roger Dean Stadium. We thank you for joining us on this very special electronic field trip. Let's go back out now to Ozzie and Neil McPhail at the Best Buy Fun Zone to wrap up today's show. Guys?
Thanks a lot, Jeff. We had a great time here, great weather, great people involved. Independence Middle School, congratulations. You did a great job.
All right.
We'd like to thank all the people who called in, everybody that was involved. You had great questions and got involved. It was wonderful. I'd like to really thank Ozzie Smith for all his work he did for us. Thank you, Ozzie.
Well, thank you very much, Brian. Thank you. On behalf of the Hall of Fame and Best Buy, we want to thank all of the students out there who participated today, and thank you, Independence Middle School. We really appreciate your enthusiasm. Thank you.
Okay, thank you, Ozzie. Neil here from Best Buy in this wonderful fun zone. Thank you so much, Neil.
Well, you're certainly welcome. You know, Best Buy's Children's Foundation is about making learning fun, and I hope everybody had as much fun today as I did. For those of you who signed up for our Teach Award grants, please check our website. We have listed the awards there. Thanks.
You betcha. We'd also like to thank Ball State University and the National Baseball Hall of Fame. Enjoy physics, whatever you do. Try to figure it out and have a great day. Wait. Impulse is the contact time times force times something else. Okay, I had to get that out. Right?
A projectile, such as a baseball or a fly ball. The Magnus effect is a force perpendicular to the forward motion of a spinning object through a fluid or gas. This is why a baseball can curve. What is that yet? Can you splice that? Add in another.
Baseball is really a fun way to teach Newton's laws, because in baseball there is so much of Newton's laws, like inertia. An object at rest or in motion stays at rest or in motion. Oh no, just tell me this isn't going on bloopers.